Two AI models can sit 1 point apart on a leaderboard and still feel completely different when you actually use them. That is why AI benchmarks are starting to break. Not because testing AI is useless, but because the old scoreboard is struggling to answer the question everyone cares about. Which model should I trust for my real task? Benchmarks became popular because they gave a messy field a simple number. A model answered math questions, coding problems, science prompts, or reasoning puzzles. Then everyone could compare the scores. For a while, that was useful because the gaps were large enough to see. Now, the top models often bunch together. One model wins a math benchmark, another wins a coding benchmark, a third feels better in chat, a fourth is cheaper and faster. So the headline says winner, but the user experience says it depends. A benchmark is like a standardized exam for a model. It gives the model a controlled task, collects the answer, and turns the result into a score. The hidden assumption is that better test performance means better general ability. That assumption is useful, but only up to a point. Imagine a school where everyone studies the same old practice tests for years. Eventually, students get very good at those tests. But that does not prove they can handle a messy project, a confused client, or a problem written in a totally new style. This is benchmark saturation. A test loses signal when too many strong models approach the top of the scale. If nearly everyone gets a high score, the benchmark can no longer separate deep capability from small quirks in prompting, grading, or formatting. On a saturated benchmark, a tiny difference can look dramatic on a leaderboard. A model ranked first may not be meaningfully better than the model ranked fifth. The ranking can change because of prompt wording, sampling randomness, or how strict the grading script is. The ceiling also changes incentives. Once a benchmark becomes famous, labs, developers, and open source communities naturally pay attention to it. They study what it rewards. They improve against it. That is normal research behavior, but it makes the test less independent over time. Then there is contamination. Large models learn from huge collections of internet text, code, books, forums, papers, and synthetic data. If benchmark questions or very similar examples appear in that training mix, the model may partly recognize the test instead of solving it fresh. This does not mean every high score is cheating. Contamination can happen accidentally because public benchmarks are public. They get copied into tutorials, blog posts, GitHub repos, and discussion threads. The more famous the benchmark becomes, the harder it is to keep it clean. There is also a softer version. A model may never see the exact question, but it may train on thousands of benchmark-style questions. It learns the shape of the exam. It learns the tricks. That can raise scores without proving the model is equally reliable in the wild. This is a classic measurement trap. When a number becomes the target, the number can stop being a good measure. In AI, the leaderboard starts as a window into capability. Over time, it can become a game that models and builders learn to play. If this kind of AI literacy helps you separate real progress from marketing noise, consider subscribing. We will keep unpacking the mechanisms behind the headlines, without treating every new leaderboard as a magic crystal ball. The biggest misunderstanding is thinking one leaderboard tells you the best model. It usually tells you the best model for that benchmark, under that setup, with that prompt style, that scoring method, and often that amount of compute allowed during the test. For modern AI agents, the testing harness matters a lot. The harness is the surrounding system that gives the model tools, files, memory, retries, and instructions. Change the harness, and the same model can behave like a careful assistant or a confused intern. Coding benchmarks show this clearly. Older coding tests asked models to write small functions. Newer tests ask them to repair real issues in real codebases. That is closer to actual software work, but it also means the agent workflow around the model matters much more. A coding agent does not just answer once. It reads files, searches, edits, runs tests, sees errors, and tries again. So, are we measuring the model, the tools, the retry strategy, the test environment, or the whole system? Usually, we are measuring a mixture. Tool use is one of the biggest gaps between test scores and real usefulness. A chatbot can sound brilliant, but if it calls the wrong function, passes the wrong parameter, ignores an error, or invents a tool that does not exist, a real workflow can fail. Good tool use includes knowing when not to use a tool. If a calendar tool is irrelevant, the model should not call it. If a database field is missing, it should ask. Many benchmarks now test this because confident wrong action can be worse than no action. Real users often do not need a model that gets one spectacular answer. They need a model that gets the boring details right every day. Reliability means following instructions, keeping formats stable, handling messy inputs, and failing safely when the task is outside its reach. Benchmarks usually sample a slice of reality. Your actual use case may live in the corners. Maybe the document is badly formatted. Maybe the customer uses slang. Maybe the codebase has old dependencies. Maybe the answer must obey a policy that the benchmark never checked. Speed also matters. A model that scores slightly higher but takes much longer may be worse for customer support, coding autocomplete, voice assistance, or live research. In production, latency is not just a comfort issue. It changes what the product can actually do. Cost changes the answer too. A powerful model may be perfect for rare expert tasks, but too expensive for millions of daily requests. A smaller model with a lower score can be the better choice if it is fast, cheap, and accurate enough for a narrow job. A single average score can hide the thing you care about most. Suppose a model is excellent at legal summaries, but weak at financial tables. If the benchmark mixes both tasks together, the average may look fine while your specific workflow breaks. Some leaderboards use human preferences. People compare two model answers and choose the one they like. This captures tone, clarity, and helpfulness better than many automatic tests. But preference is also influenced by style, length, confidence, and what the crowd happens to ask. A model can win preference votes by sounding polished. That is useful when the answer is correct. It is dangerous when the model is wrong. In real work, a humble model that checks uncertainty may beat a fluent model that turns mistakes into beautiful paragraphs. Here is what we know. Public benchmarks can saturate. Contamination is a real concern, and real workflows depend on more than raw accuracy. What we should not assume is that benchmarks are dead, or that every impressive score is meaningless. Benchmarks still matter because they give us shared language. They reveal progress, expose weaknesses, and let researchers compare systems in public. The problem is treating them like final verdicts instead of instruments. A thermometer is useful, but it does not describe the whole weather. The response is not to stop testing, it is to build better tests. Some newer evaluations use fresh questions, private test sets, real tasks, expert rubrics, live environments, or tool-based workflows. These designs try to make memorization harder and usefulness easier to measure. Rolling benchmarks are one answer. Instead of freezing the same test forever, they add new tasks over time. This makes it harder for training data to contain the exact answers. It also helps the test stay difficult as models improve. Private tests are another answer. If the exact questions are not public, models are less likely to train on them directly. But private tests also require trust. Users need to know who wrote the tasks, how they were graded, and whether the results are reproducible. For companies and builders, the most useful benchmark is often their own workflow. Take real examples from your product, remove private data, define what a good answer means, test several models on the same cases, then measure accuracy, cost, latency, and failure behavior together. A practical eval set does not have to be huge at first. Start with 20 to 50 examples that represent your hardest common cases. Include normal requests, edge cases, bad inputs, and tasks where the model should refuse or ask for clarification. When you compare model claims, ask what was actually tested. Was it the base model, a chat version, a reasoning mode, or an agent with tools? Were retries allowed? Was browsing enabled? Were costs counted? Was the same prompt used across all models? Also look for variance. If a model succeeds 9 times and fails once, that one failure may matter if the task is medical, legal, financial, or safety critical. For high-stakes uses, the question is not just how often it wins, it is how it fails. Good evaluation reports show slices, not just one number. They break results down by task type, difficulty, language, tool category, and error pattern. A model that is average overall may be excellent for your niche. A leaderboard champion may fail your exact slice. When a model launch shows a dramatic benchmark chart, slow down. Ask whether the benchmark is saturated. Ask whether it is public. Ask whether the task matches your use case. Ask whether the chart includes speed and cost. A screenshot is not a deployment plan. The better mental model is simple. A benchmark score is a clue, not a verdict. It tells you where to look next. The real question is whether the model can do your task under your constraints with acceptable failures at a price and speed you can live with. As AI becomes more agentic, evaluation will look less like a school quiz and more like a driving test. The model will need to navigate, use tools, recover from mistakes, follow rules, and know when to stop. That is harder to score, but closer to reality. So AI benchmarks are not breaking because measurement failed. They are breaking because the models, the products, and the incentives outgrew simple scoreboards. The next era of AI evaluation will be less about crowning one winner and more about matching systems to jobs. What benchmark claim have you seen that sounded impressive but confusing? Drop it in the comments or suggest the next AI topic you want explained. The best questions often reveal the hidden mechanism behind the hype.